Welcome back to the Science Hub SKB. Working like a Scientist, Part 8. Our learning objectives are guidelines for constructing a graph, what is the gradient or slope of a graph, and the importance and shapes of graphs. Guidelines for constructing a graph. 1. Identify the independent and dependent variables. Place the name of the independent variable on the x-axis and the name of the dependent variable on the y-axis. Name the axes. Place the unit of measurement for each variable in parentheses. 2. A title that clearly includes the independent and dependent variables should be written at the top of the graph. 3. Select numbers for intervals that are easy to subdivide, for examples, multiples of 2, 5, or 10. And finally, 4. Use a sharp pencil for plotting data points. Draw the best fit line or curve with approximately the same number of points above the line as below. So meeting the guidelines for constructing a graph, we have a graph right here where we have length against force. For the y-axis, the word length is written right there and the unit is next to it, and for the x-axis, the word force is written there with its unit. The points are drawn clearly and it has a best fit line passing through it, and the graph is completed with a title. Gradient or slope of a graph. The gradient or slope m of a graph can be determined by using values along a straight line. The values may be plugged into the following equation, where we have the gradient or slope, which is m, is equal to the difference in y2 and y1 divided by the difference of x2 and x1, or m is equal to the difference of y1 and y2 divided by the difference of x1 and x2. Gradient or slope of a graph. Using the values of the table, try to plot the following graph. Give the graph its appropriate labels and title, and then determine the gradient or slope of the graph. Let's get started using the information from the table on the right. Table showing the results obtained for how the length of a spring is affected by the force applied to it. So from the beginning, we have to determine which one of these would be our independent variable and which one would be our dependent variable. Did you come up with it? What is the cause and what is the effect? In this case, the cause would be the force applied and the effect would be the length of the spring. And exactamundo, so we have our length on the y-axis, which is our effect, and our cause, which is on the x-axis, is our force. Okay? Alright, so take some time to plot your graph. And now once we have that already figured out, we're going to start plotting our points where we see when the force is 0, the length is 0. When the force is 1, the length is 1.5. When the force is 2, the length is 3. And when the force is 3, the length is 4.5. When the force is 4, the length is 6. And so we have generated our points, and now we're going to put in our best fit line. Everything you do, you should use a sharpened pencil and a ruler. To find our slope, we're going to put our x's. Our x's should look different from the original points. So the first of the points would have been dots. As you can see, the pink dots. And so we're going to use 2 points on the line that we did not plot to solve for the slope. And we have this point right here above here and this point below here. So 2 points, 2 random points on the line that are new and fairly far apart. Make sure when you are plotting these points, this point and this point, it would have been that the line passed through across here. Across here meaning like the line passed through lines that cross over one another. Alright, so now that we have our points, we're going to label our points either 1 or 2. So the top point is labeled point 1 and the bottom point is labeled point 2. And that we'll do in our head. We assign each point a number, and so the top point for this one is 1 and the second point at the bottom is assigned point 2. We have to determine the x and y coordinates of those points we just plotted. So see the first point, determine our y coordinate here, and then we're going to determine its x coordinate from down here. And we get y1 equal to 6.3 and x1 is equal to 4.2. Okay, and then for y2 we have y2 is equal to 0.5 and then x2 is equal to 0.3. Awesome sauce, guys, if you got that. And now to solve our gradient, we pick one of the equations from the page before and we just substitute our values in. So y1 minus y2, we have 6.3 minus 0.5 centimeters, and we always put our units as well, divided by 4.2 minus 0.3 newtons. Again, we put our units there, and we get 5.8 centimeters divided by 3.9 newtons to give us 1.5 centimeters per newton. Awesome sauce, guys, if you got it. And then to complete the look, we add our title, which says graph showing the results obtained for how the length of a spring is affected by the force applied to it. If you notice again, our title for the graph is exactly like the title of the table. We just changed the word table showing to graph showing. Awesome sauce, everyone, if you got everything correct. Gradient or slope of a graph. The slope of a graph, no matter how large a triangle or how far apart points, should always be the same or very close in value to each other. For any point on the graph, dividing y by x should always give the same or similar number, which we call m. Scientists and mathematicians use the letter m to show that this result, called a quotient, is constant. The whole graph can be represented by one mathematical equation where y divided by x is equal to m. From this equation comes another one, y is equal to mx. So for this graph, we know that our gradient is 1.5 centimeters per newton. Let's try to move the x's somewhere else and see if we get the value for the slope to be the same or similar in value. So we've moved the x's and they have different x and y coordinates, as can be seen. The first point has a y coordinate of 4.2 centimeters and an x coordinate of 2.6 newtons, while the second point has a y coordinate of 2 centimeters and an x coordinate of 1.3 newtons. If we stick this into the equation for the slope, we actually get 1.3 centimeters per newtons. It is very close to the original value. The importance and shapes of graphs. Graphs not only communicate information effectively, they are also used to estimate values or readings that are not obtained experimentally. The shapes of graphs indicate how the variables on the graphs are related quantitatively, serving as a useful means of interpreting data tables. Mathematical equations can also be obtained from these relationships, and values for a wide range of variables can be obtained without performing the experiment to get data. Shape of a graph. A straight line graph that passes through 0, or the origin, represents the mathematical relationship of y equals to mx. The relationship between the y and the x variables is called a direct relationship. The graph is said to be proportionate. While if you get a straight line graph that does not pass through 0 but crosses the y-axis instead, it represents a general equation of y equals to mx plus c. M represents the slope and C represents the point where the line crosses or intercepts the y-axis. The graph is said to be linear. Another type of relationship between variables is one where one variable decreases and the other increases by the same factor. This type of relationship is an inverse relationship. A graph like this one on the right is an inverse variation graph. The curve is called a hyperbola. K is a constant that controls how spread out the curve is. The graph never touches the x or the y-axis. They are asymptotes. As x increases, y decreases, and vice versa. Investigations involving graphs. If time permits, 1. You can execute and write up a lab report on periodicity and determine how the length of a pendulum affects its period. 2. You may execute and write up a lab report on bounces and determine how the height a ball is dropped from affects the number of bounces. Questions 1 through 6 are about the graphs shown. 1. In which graph does the value of y increase then remain constant? 2. Which graph represents the relationship y equals to mx plus c? 3. In which graph does x increase as y decreases? 4. In which graph does y increase as x increases? 5. In which graph does y equal to k over x? And 6. In which graph does y equal to mx? You may pause the video and analyze the graphs carefully. Did you get these answers? In which graph does the value of y increase then remain constant? That's D. Which graph represents the relationship y equals to mx plus c? That's C. In which graph does x increase as y decreases? That's B. In which graph does y increase as x increases? That is A. In which graph does y equal to k over x? That is B. And in which graph does y equals to mx? That is A. Did you get all of these questions correct? Did you get some correct? I hope it went well. Great job for trying. Questions. The graph below shows the heights of two girls as they grow up. 1. Which girl is taller when they are 10 years old? And 2. At which age are the girls the same height? You may pause the video to analyze the graph and observe the trends on the graph to answer these questions properly. Did you get the first question correct? It is Jean. Jean is taller than Sylvia. And the second question is at age 6. They are both at the same height. Great job, students. Thank you for watching the final installment of Working Like a Scientist. See you around for the next series. Bye.